How's it going, everyone? Hope you're all having a good day so far. Last time, did we talk about the? We talked about the project last time, right? Thank you. The days get scrambled up sometimes. Um, it's a little bit better now after we had after Labor Day because now whatever I teach on Thursday of one week is what I now teach on Monday of the following week. So it's good and bad in a way, but okay. Anyway, that means today we're going to go over our we're going to go over chapter 4 basically. Um, anyway, all right. Now our discussion in chapter 4 is going to be a little bit abbreviated. We're just going to hit the main points really. But chapter 4 is on linear regression. And also correlation. You might have noticed last week I uploaded the notes for this chapter into Canvas, and if you didn't, I uploaded the notes from chapter 4 into Canvas, so you can feel free to look at those. The formulas that we end up working with are kind of painful. Might be one word for it. But yeah, it does take some work to get through these things. All right. So let's go through this, and I'll switch back and forth to the computer as we need to, and I'll show you how to do this by hand and also on the calculator. But before we get to that, of course, we have some definitions to start off. First of all, we have correlation, which is a method to determine. It's really a measurement of the relationship between two variables. Okay. It seemed to have gone off the screen. There we go. Excuse me. So when I talk about how two variables are related to each other, that what we're really looking at is how much influence does one variable have on another. If there's a positive correlation or direct correlation, in this case, it means that there is a direct influence on from one variable to another, which means that if whatever one variable does, the other exhibits similar behavior. Not exactly the same, but similar at least. And we contrast that with negative or inverse correlation. In which the variables display opposite behavior. Okay, so correlation could be positive or negative, and it's actually measured from -1 to 1. So a value of 1, which is very unusual, means that there's a very strong positive correlation between the two variables, and they have a direct influence on each other. And a correlation value of -1 means that they have a very negative or strong negative correlation, which means they have basically opposite behavior from each other. Now, when we say opposite, that means it's not necessarily a bad thing. It just tells us what's happening in a given situation. So if we get a correlation coefficient of -1, it means that they do display a correlation, but they're going opposite directions, is really what it amounts to. Probably the best way of saying that, let me see if I got it written down. I don't. Yeah, the best way to say it is that if one of the variables is increasing, then the other is decreasing. That's what a negative correlation means. So, if they're a direct correlation, that means if one increases, the other increases, and if one decreases, and the other decreases. That's what direct correlation means. They're basically doing the same thing. It may not be at necessarily the same rate or same amount of change, but they are both changing in a similar way. Okay. So that's what correlation is, and then we measure it not only from -1 to 1, we also, if we wanted to, we could break it up a little bit further and say, well, if the value is 0 to 0.3, it's a weak correlation. From 0.3 to 0.7 would be a moderate correlation, and then 0.7 to 1 would be a strong correlation. That's for positive and negative. So we could go a little bit further and comment on that specifically. So that's another way we can talk about the measure of the correlation. If something is zero correlation means there's no relationship between them. These don't affect each other, basically. We can't find any connection between the two variables, and we think that they don't really have any influence on each other based on that. And it may not be entirely the case, but it sure would seem to indicate that. Okay. If you look on the, let me switch to the computer screen. If you look on our, this is the document I uploaded into the notes. And so here's the discussion on correlation right here that I just went over. It doesn't mention moderate correlation, but that's in between strong and weak, basically, as you might expect. All right. We'll get to the correlation coefficient in a moment, but as you can see, the formula is a little bit intimidating. Might be a good word for that. But I'll try to go over an example and kind of show you how to work it out by hand before we dive into using the technology to do it. But we'll abandon doing it by hand very quickly to use the technology. But we'll get to that in a moment. Let's talk about regression next. And I'll switch back to my notes. Now, regression is directly related to correlation. Basically, in regression, we already know that there's a relationship that exists based on the correlation, but we're trying to figure out, okay, what kind of relation? Is it linear? Is it nonlinear? Which we're not going to dive into nonlinear, but and again, if it's positive or negative, we can kind of demonstrate that with our graph. So regression is knowing that there is a relationship between the variables do they have a linear or nonlinear relationship? And if it is linear, how can we find the line that best fits the data? Okay. So that's what regression is. Now, for regression, we move on to what is called a scatter plot or a scatter diagram. This graphs ordered pairs of data x and y. Okay. X in this case is our independent or explanatory variable, as we call it. And y is our dependent or response variable. And in this case, the x and y value come from the same individual that was part of the sample. Okay. So for each ordered pair, x comma y, sorry, for each ordered pair x comma y, the values come from the same individual. Hold on one second. Okay. So for each ordered pair x comma y, the values came from the same individual. Let's look at what a scatter plot might look like. And the idea is that on our graph, here's our x and here's our y. We put the data together and we'll get some different points on the graph. Okay. And what we try to do, what the purpose of doing the linear regression is trying to find the equation of a line that best fits the path that the points are following. Okay? And so we see with our points that we have a general trend upward to the right. And so it seems like a line such as this might be a pretty good indication of what's happening with these coordinates here. Okay? So we have a scatter plot with a regression line superimposed, basically. In this case, because the line is moving upward to the right, this would indicate a positive correlation. But we're not quite sure how strong, based on how close or how far the points are from this line. So depending on where our information lies, we could have some different things happening. These seem to be a little more haphazard, but there does seem to be a general trend moving downward to the right, and I probably should have drawn it a little bit lower than I did, but you get the idea there. In this case, because the points are farther from the line, I would say that we would have a lower correlation coefficient based on this, closer to 0, basically. Not 0, but it might be a weak correlation, for instance, but still negative, it turns out, because there's a downward slope. So this one, just looking at it, I would say moderate to strong correlation based on how close the points are to the line. And in this case, we have a negative correlation. And I would say it's weaker because the points are farther from that line. Okay. In fact, the way that we calculate this line is based on what we call a least squares approach. And this is well beyond what we need to cover. So, least squares means, on average, what line can we create that the distance from each point to this line, the square of that distance, is minimized. Okay. And that's what a least squares regression line is. But we're just going to call it a regression line and not worry about necessarily the process, because, again, the calculator is going to do the actual number work for us. So, okay. So let's look at this correlation coefficient. Okay. On the numerator, we have n times the sum of x times y minus the sum of the x's times the sum of the y's. On the denominator, we have a square root and a bracket inside that. N times the sum of the x squares minus the sum of the x's in parentheses squared, close bracket. And then we have a similar term but with y's instead of x's, so n times the sum of y squared minus the sum of the y values squared, close bracket. Okay. So that is our formula for calculating R, the correlation coefficient. Now, what I thought we would use for this is the data that we have for the project, just to kind of demonstrate what we can do here. Now, you'll remember I talked about the variables being either the independent or explanatory variable for x, or the dependent or response variable for y. So I'm going to go to our data for the project and pick out two variables, one where where one clearly depends on the other. Okay, let me switch to computer screen. So we go to project files and with the PDF. I'll zoom in. Okay. So when we talk about calories, there's actually a formula used to calculate calories, which is based on protein, fat, and carbohydrates. So what we can do, let's choose what can we choose? Let's choose protein and calories. Okay. We'll choose protein and calories as our two variables. because calories depends on partially on protein, that means we can let protein be our x. Let me get back on screen. And we'll use calories as our y value, because there is a dependence there. The other thing I'm going to do is we're not going to use all 50 values because we don't have enough time to do all that. But we can pick out 6 values, for instance, and it'll be relatively simple. And what I'm going to do is pick 6 numbers at random from the list of 50 that we have. So we're going to use our random button, which on this calculator is right above here. So you see where it says random. So second and random. Okay. Now I want a random integer between 1 and 50. So put 1 comma 50 inside the parentheses. And I press enter, and it gives me 38. So I can mark down the number 38. And if I just press enter again, it repeats the process, gives me 37. And I'll keep going until I have 6 different numbers to work with here. So 29, 27, 40, and 39. It seems not random because they're all clumped together, but that's part of randomness, as you never know. It's kind of a silly statement. Alright. So what I'm going to do is I'm going to go back to the data and look at line 38 and record the protein and the calories in their respective columns. So 38, they had 12 grams of protein, and their snack had 170 calories. 37 had 3 grams and 170 calories. We're off to a great start. Number 29 had 2 grams of calories, 2 grams of protein and 210 calories. 27 had 1 gram protein and 35 calories. 40 had 2 grams and 130 calories, and 39 had 4 grams and 230 calories. I'll be honest, this data is all over the place, so I have no idea what we're about to get as results go. So anyway, so that's our data. Now, I'm going to expand this table, as we also need to find x times y, x squared, and y squared. And then at the end, we'll have to add each column together. Okay. If you recall from the formula that I wrote down, which you can see here, I want to add up all the x's times the y's, all the x's, add up all the y's, add up the x squares, and add up the y squares. That's all 5 of these columns right here. So we'll need the sum for each one of those to be able to plug that into the formula for R. So we'll do x times y first, so we just go across. X 12 times y 170. is 2040. 3 times 170, that's 510. 2 times 210 is 420. 1 times 35 is 35. 2 times 130 is 260. And 4 times 230 is 920. This column, we want to square all the x values. So 12 times 12 is 144. 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. And then 4. And 4 times 4 is 16. Lastly, we do y squared. So 170 times 170 would be 28,900. For both numbers, it is 900. 210 times 210 is 44,100. 35 times 35 is 1,225. 130 squared is 16,900. And 230 squared, what is that, 52900? Yes. Okay. Okay, next step, we add each of our columns together. For instance, this first column is 12, 15, 17, 18, 24. Calories, we know it ends in 5. Let's see. 14, 15, and then 9 makes 24. So put down the 4, carry 2, 3, 4, 5, 6, 7, 8, 9. So 945. And we keep going with the rest of them. 5, 8, carry 1, 6, 10, 1, carry 2, so that is 4. Let's see, 144, and 18, be 162, 178. This one's kind of crazy. I may just do it on my phone or calculator. I'm going to do that on calculator. I came up with 108,825. If y'all are also working this at the same time, please let me know if I made a mistake. Because I actually did last time. In my other class, I made a mistake here. At least I didn't seem to repeat my mistake, so I'm happy about that. Although it was 6 different numbers I chose for the other class than this one. So, anyway. What is n in this case? N is the number of data values. So how many data values do we end up using here? Six, yes. So n is 6. This is the sum of the x's. The sum of the y's. This is sum of x times y. This is sum of x squared. And this is the sum of the y squares. Okay. So we're going to take these 5 values, including n equals 6, and plug them into this formula. So I start off with 6 times the sum of x times y minus the sum of x times the sum of y. So n 6, sum of x times y, 4185, minus the sum of the x's, 24, times the sum of the y's, 945. On the bottom, square root first of all, bracket n times the sum of the x squares, 178, minus the sum of the x's, 24, in parentheses squared, and then n, again, 6 times the sum of the y squares, which is 108,825, minus the sum of the y's, which was 945, squared. Close bracket. There we go. Alright, what I would recommend in this case is rather than doing it all at once in our calculator, we'll calculate it one piece at a time. We'll figure out what the numerator is. That we can do that all in one step. We can do inside one bracket here, and then we can do inside the other bracket, and then we'll actually calculate it from there. So looking at the numerator, we have 6 times 4,185 minus 24 times 945. So I come up with a value of 2,430. Okay. First part of the denominator, we take 6 times 178 minus 24 squared. I get a value of 492. Then over here, 6 times 108,825 minus 945 squared. I gotta use parentheses there, sorry. 6 times 108,825 minus 945 squared. Yeah, and I appreciate that, Crystal. I'm running into a problem here because this should be a positive number. And that's exactly what's happening, is that it had miscalculated this value over here. No, it was a miscalculation on my part. That's perfectly fine. So you said 172, 925. Okay. Just a little bit off. It's only off by 64,000 and change. That's quite a bit. That should fix this issue I'm running into, because there's no way that we should end up with a negative number here under the square root. If you've ever done any algebra, then the square root of a negative is actually an imaginary number, and we don't deal with imaginary numbers in statistics. 6 times 172, 925. Minus 945 squared. Yeah, this gives us a much better number. It's positive, that's the main reason, but 144,525 Okay. And so now we have this. Let's go ahead and enter this all in and calculate from there. So we take 2,430 divided by the square root, and I'll open in the square root, let's put parentheses there, so it'll be, what is that? 492 is the first number, times 144,525, close parentheses, equals, so we get 0.288. Okay, so this is our correlation coefficient, and just looking at this, this is a weak positive correlation. Okay. It's possible that this number on top is negative, in which case we'd end up with a negative correlation. But we do know that protein and calories share a connection, because the formula for calories includes protein as one of its variables, as well as carbohydrates and fat. And I forget the ratios exactly. I think it's 4 times protein, 4 times carbohydrates, and then 9 times fat, but I'm not quite positive on that. Anyway, and then we divide by something, and it's been a while since I actually saw that formula, so I apologize. But we know there is a correlation there because of that connection. It turns out in this case it's relatively weak, but if you remember what I said before, I was looking at these data pairs, and I kind of felt it was all over the place, is what I said before. There really wasn't a whole lot of connection here, it seemed like. And that kind of is borne out by this result that we got, that it is, in fact, a weak positive correlation. We did confirm there's a positive correlation, which is good, because there should be. In this case, it's pretty weak, based on the 6 data values that we choose in particular. These 6 are fairly inconsistent, I would say, and as a result, we end up with a relatively weak correlation. One of the things that we're able to do is to actually go into our graphing calculator and use that to create a scatter plot and actually show a line of regression. This is what I end up with for my other class, for instance. You can see the 6 data points, and then the one really weird one out here, and then the line that resulted from that. Okay, so we'll be able to do the same thing for our data and see what that looks like for, with our lower correlation, because they had a correlation of like 0.6 something in the other class. This one is much lower because it's a little below 0.3. Theirs is almost 0.7. It's almost a strong correlation. Just depends on which points we choose, how it ends up, basically. First thing, let me go in here and clear out the list, because we'll have to enter everything into the list. Okay. So, what I'm going to do is I'm going to take each of our x values here and put them into list 1, and then each of the y values and put them into list 2. So for the x's, we have 12, 3, 2, 1, 2, and 4. And for the y's, we want to make sure that 12 and 170 are on the same line, because they're connected to each other from being part of the same data for the same individual. So we don't want to scramble the numbers at all. We want to leave them in the same order. Let's see, 210, plus 35, 130, and 230. Okay. So that gets our data into the table. Next, what I'm going to do is I'm going to go into the catalog. Now, the catalog, if you look, is actually right here above the 0 button. So I'm going to press second and 0. The reason we want to go into the catalog, and I'm going to arrow down, is that unless we turn on the diagnostics right here, it's not going to give us the value for R. And we want it to give us R so we can compare it with the one that we calculated and make sure it's correct. Make sure ours is correct, because likely the calculator will be correct if we entered everything correctly. I don't know if you have to do that on the 84s. I know you have to do that on the 83s. I would recommend going ahead and doing it on the 84 if you have a big graphing calculator, or if you have like an app on your phone that imitates a graphing calculator. You want to go ahead and do that just to make sure it's working properly. So, let's see. So after this, we stat, we arrow over the calc, and we want to use linear regression. And so here we have linreg ax plus b. Now, one thing, before we calculate this, let's go back to the document. Not that document. The notes I had. So we talked about R right here. What I didn't talk about was the linear regression line, which is we can use y equals a plus bx or y equals ax plus b. If we choose to use ax plus b, this kind of switches everything up. Okay. I'm going to go ahead and use y equals a plus bx because that's what I have in the notes here. And that a is calculated like so, and b is calculated like so. You can see it's actually some of the same components on the denominator, but different components in the numerator, mostly. But it's kind of similar to what we did with the correlation coefficient. I didn't want to do this by hand also, because just writing on paper, I don't have a lot of patience. If I was on a whiteboard, I would probably have a little more patience writing all this down, because we have more space available is the main reason. But unfortunately, we can't keep everything on screen at once for you to see everything that's happening here. So it's harder for me to go over this. And I feel that having gone over R already, we can probably skip A and B and just let the calculator handle it. So, anyway, if you want to go back and try this, you're welcome to, and compare it to the results that we get for the calculator. Okay. All right. So, I'm actually going to use option 8 here, which is linreg a plus bx. Now, linreg, that means linear regression, as you might expect, and then a plus bx is the format. So there's really two options here, whether you want ax plus b or a plus bx. And either one is fine, but because I gave it to you in the notes as a plus bx, we'll go ahead and use that one. So you press enter. We see it puts it onto the screen. Now, if you're using the 36X or the 84s, you probably don't have to do anything at this point. You just have to press enter until you get down to calculate and get our answer. On the 83s, however, it's a little bit weird, because we actually have to enter list 1, comma, list 2 for it to understand that that's where our data is stored that we're using. So I'll press second and 1, and that brings up L1, list 1. I'll press the comma button right here, which is in the glare right there, the comma, and then I'll enter L2, which is second 2, and entered L2. Okay. So we press enter. And so we got y equals, I'm going to write this over here, a plus bx. Our a value is 137.7. Our b value is 4.9. I'll go to 2 decimal places just for a little bit more accuracy. Sorry. It gave us r squared, but more importantly, it gave us r is 0.288. Now, that is what we calculated, yes. So that means now we have it correct. There's no way to get this number without getting everything else right up to that. So this is also kind of reassuring that after I fix that one mistake, and thank you for letting me know, we did to get the right number. Okay, so we have this information. This is from the calculator. Now, to actually go through and let me move this up now. To go through and graph this on the calculator, for those of you that are interested in that, we'll go into stat plot, which is a little bit off screen there. Stat plot is actually right up here above the y equals button. So press second and y equals. Now yours is probably off by default, but mine is on because I use it every semester. If it's off, switch it over to on, and we just want the first box here shaded. And again, our x values are in list 1, our y values are in list 2. You can see it indicated right here. And for our mark, we'll just use the first one. So this right here indicates that as a scatter plot because you just have a bunch of dots on the background there. When you see it also could do a box plot, a modified box plot if we wanted to. It's not exactly like what we did, but similar. And it does have some capability for histograms, but it's not great. I'll tell you that right now. It's not great. Anyway, so we have some different stat plots we can do in here, but probably it's easy enough to do it by hand. We usually do it by hand anyway. That's why I didn't talk about it before this. But for the scatter plots, it makes a lot of sense to have the calculator do it. Alright, so press enter and go back. Alright, that's all taken care of. Then we hit y equals, and you can see the equation from my previous class, which is the a plus b times x. I'm going to clear theirs out and enter ours in. For us, we had a was 137.74 plus b is 4.94 times x. And what I did for the x is this button right here. It starts with x. I imagine if I pressed it again I'd get these other characters, but I just want to press it once just to get the x. And press enter. Okay. Next we'll go to Window. Now our x values range from as small as 1 to as large as 12. Now because 1 is our smallest value, I'm going to go a minimum of 0, one step down from 1. And for our maximum, I'm going to enter 13, which is one step up from 12. Minimum, for y, we have 35 as our small one and 230 as our big one. So I'll go a little bit smaller than 35. I'll put 25. And if 230 is our largest, I'll go up to 240. Just to have a little bit more room on either side. If we don't do this part where we change the window, basically this is the area that's displayed on the screen. If we don't change this, then we'll press graph over here and our graph will be somewhere not on the screen. I'll have to arrow over to get to it. So This will actually display it where we can see it, and we don't have to mess around with it at all, which is preferable. So we enter all this in, then we press graph, and it'll show us our regression line. And again, it does have a positive correlation. That's where we see a slight upward slope to the line. But also, because it's a weak correlation, there's actually a lot of distance between the points and the line. Okay, and that's because we had the... I think if we didn't have this one data value right here, we'd have a much stronger correlation between the rest of the data. Okay, this one data point, and the same thing happened in my other class. We had one data point that kind of threw off everything, and then otherwise it would be a very strong correlation between these, I think. Now, I'm not going to make you do any of this right now. There will be a problem on the final, though, where we'll have to find the correlation and the equation line for regression. So the numbers will be a little bit smaller than what we have here. We won't have like these triple-digit numbers where it makes everything really large. So it'd be more manageable to do it by hand on the final if you prefer. I do recommend you try to use a calculator, because at least we know if we get everything in it entered properly, it'll be exact. But anyway, even though I'm not going to give you any homework on this right now, I want you to go ahead and try it like I've done here. Pick 6 values at random from our data set. Get the X and the Y value, and we, instead of protein and calories, if we wanted to do carbohydrates and calories or fat and calories, probably fat and calories would give us a much higher correlation. It should give us much higher correlation, because it has a stronger value in the formula for the calories, I think. So anyway, I would recommend you try to repeat this project on your own. Now, on the final, you won't have to graph it. So one thing that we can do, if you don't have a graphing calculator, on the smaller calculator, and this has my data from the other class in there still, but even if we just have the data plugged in, like the 6 points for X and the 6 points for Y, if we go into stat and down to linreg, this one only gives us the one option, AX plus B. We go through, and this is how it would be on the 84 also. X data is in list 1, or Y data is in list 2. Frequency 1. Whatever this is, don't worry about that. And then just go down to calculate and enter. And it'll give us everything that we need right there. Okay, and you can see my other class had a higher correlation coefficient, 0.506. So it wasn't as strong as I thought it was, but it was moderate. So, and then so we have our A and our B value right there, A and B, and then our R, and those would be the three things that we asked for on the final. So that'll be very easy to do in this calculator and in the 84. The graph, I think the graph is nice that we actually can see visually what the regression is looking like, and the line of regression superimposed on top of it. So anyway, so I would at least recommend trying to find the line of regression. You don't have to graph it necessarily unless you have a graphing calculator. If you want to try that, I definitely recommend that. But again, no formal homework assignment. Feel free to try that stuff out, and this is a good opportunity to keep working on your project. At least one person has already turned it in, so that's good. But again, you still have until next Wednesday, I believe is what I said, the 14th. So you still have until then to turn everything in. Um, so again, you may want to take this opportunity where we have no homework assignment to spend that time working on the project some more. Probably, I don't know how much time it has taken the rest of you. Most of my students tend to spend, if they're working steady, between 2 maybe 4 hours at most. Okay, keep that in mind, and don't wait till the last minute, please. Okay. So that's all that we have for today. We'll go ahead and stop there. It's a little bit early, but I don't really want to start anything else now at this point. So we'll stop there, and you all have a good rest of the day, and I will talk to you again on Wednesday. Y'all take care. Bye. You too. Thank you.